privacy and security area, we have some pole position companies, so do check out. And my session is not going to be classic ML and DS. It is going to be more of an orthogonal concern. Say you build the best ML model and the DS model, and now you put it in production, how to make it run smoothly and how to make your customers are going to trust your entire product. So this is going to be a little bit conceptual and less on a bit of a technical as well, because I kept it much technical light. I didn't go too much into box diagrams and architectures, but invariably some things will come. So stay with me on that. So quick intro. We are a leading customer data platform provider. Our primary markets are in EU, UK, and MENA region at this point in time. We don't operate in India as a market. And I come with some 22 years of experience, and fortunately, I have been on the big data trend ever since it started way back in 2012. And I've been staying on with that, building data platforms in multiple companies, the latest one being Zeotap. And why are we here? This is the evolution of companies. If you go pre-2010, every company will claim we are there in the transformation journey, we are a technology company. Okay, we use technology was a trend at that time. And by 2019, every company became like, oh, we are a technology company, we are a technology first company. Then by 2023, that trend completely changed, and everyone became a data company. You talk about any digital natives, any company, now they're like data-driven, data is the new oil. Ambani goes on stage and says data is the new oil, so everyone becomes a data company. Now, post-2023, what has happened is everyone wants to jump onto the AI bandwagon. Everyone is becoming an AI company. What this means, there is a deluge of data, and there is a deluge of data products and AI products which are going to come into the scene, okay? And what else is maturing? If you look at this is a Gartner hype cycle. If you look at it, there is a bunch of data keywords you will observe, and none of them have gone to the plateau of productivity. This is the opportunity we are talking about in terms of the data companies which will come out of India, around the world, and India definitely, as in the previous session stated, has a very big opportunity there. You'll search for the word data in all these places. It'll be either in the slope of enlightenment or in the peak of inflated expectations. Especially if you look at it, there is a data product which is just entering the peak of inflated expectations in terms of this thing. How do you meet the expectations? So that is what we are going to see in this talk. The second thing, multi-tenancy. Since I assume many of the audience come from a AI and ML background, so multi-tenancy is a concept in terms of, it started with software where they hosted something on the cloud, and every customer gets a tenant for themselves and they're able to operate on that. It brings a bunch of challenges in terms of how you operate your product as a whole. I just put a word art of what are the challenges which will come. You will have the noisy neighbor problem where one neighbor is cannibalizing the other neighbor's services. Then you have these various concepts of shared nothing architecture, hybrid architecture. Then multi-tenancy, the two important things is you need a attribution, proper attribution of who's utilizing how much of your resources. Then the other thing is the context changes. You will have a vertical context. You might have a customer who comes from a telco background. You will have a customer who will come from a retail background. You will have a customer who will come from BFSI or a finance background, right? So you have all these contexts, the vertical context, then also the org-specific context. Each org will come and put a condition in terms of how their InfoSec policies is going to be, what they're expecting in terms of how your product has to operate in the environment. So all these challenges come into the play. Then there is a separate thread which is happening, which is called the observability. The key, I would say, inflection point for observability as a story started in 2003 when Google released its SRE paper, or the Site Reliability Engineering. I just put the definition. It is about building, operating highly reliable, scalable, and efficient systems by applying software engineering principles to IT operations. So data observability is an evolution of this particular concept, and I just put this thing showcase of how everything else is remaining. And in 2016, there was another inflection point by this gentleman called Peter Borgen. I have put it in a 2017 highlight. So he called about 3 pillars of observability: logs, traces, and metrics. So this is called as the 3 traces of observability, and we'll be looking at how we cross-position many of these into the data observability arena. And by 2024, you know, it is the AI deluge is happening, and Gartner has released a magic quadrant. Think about it. Observability as a concept comes from control theory way back in 1960, but the Gartner concept of the chart has come only in 2022. That is the opportunity we are talking about here. Now, with that, with so much of observability evolution happening, what is data observability? So, to just tell you how easy it is, you know about this concept, this Japanese concept of ikigai. So that means living a peaceful and worthy life. It is a amalgamation of this bunch of concepts in terms of how you are able to do what you love, what the world needs, what you get paid for, and what you're good at. Simple concept, but really difficult to follow. Observability is probably going to give that zen in terms of how you're running your products, but you just search the literature, go to internet, go to Gemini, go to ChatGPT, search the literature, what you're getting in observability, this is what you will get. You will get a bunch of pillars. Somebody will say lineage, volume, freshness, this is the pillars. Another will say LTM is the pillars. Another will say OEC is the stack. Then observability itself is increasing in terms of version 1.0, 2.0, dynamic observability. You will hit this moment in terms of WTF, what is happening here, right? So now, zero-tap by definition, so I just put another this thing based on the previous slide in terms of, there was a talk about what big data was way back in 2013. So observability in a similar scenario, everyone talks about it, nobody really knows how to do it, everyone thinks everyone else is doing it, so everyone claims they are doing it. So this is the reality at this point in time in terms of how observability and especially data observability is happening around the world, not just in India. So we had to release our platform way back in 2020, the new version of the platform. So we went back to the first principles in what exactly we are trying to achieve by putting these concepts. So at the end of the day, that is a noun. So from the noun, what exactly we are trying to achieve. So before that, I'll tell what the platform is meant to do. So we are meant to deliver a real-time data product, which is surgical about customer intelligence delivery, collection, in process, storage, and distribution delivery to the MarTech and AdTech ecosystems for various customer engagements. It can be for customer acquisition, it can be for churn prevention, cross-sell, upsell, you want to retarget, you want to reacquire the customers, so for various kind of use cases. So a classic fan-in of data, a fan-out of data in various modes. And if you think about it, this product is going to sit as part of the ecosystem. It is not like a standalone product. If I put it in an enterprise, it has to talk to multiple systems and it has to talk back to multiple systems. So that is the thing. And what we provide as suite of product is we provide customer intelligence, customer 360, resolution strategies. We have provide real-time orchestration journeys. We have predictive models. We have audience segmentation. And the most important thing, by virtue of operating in EU and UK, we provide a consent. So consent will come to India very soon. Beware, everyone who's working on AI and ML, the DPDP law is in the draft form. It might hit by this winter session. So consent is already very, very sensitive topic in EU. So that is another thing which the product offers out of the box in terms of how we handle that. Now, just to conceptually differentiate between the previous generation of AI software or the data software like the Snowflakes or BigQueries or the Databricks of the world, and what these new age of data products are coming into fore is the previous ones, they'll come and sell the infra and the tool, right? In terms of, okay, this is a tool, you bring your set of engineers, let them operate on top of it. But whereas data products, there is this third row which you see, which is called the data ownership, okay? So we, by definition of providing a data product to the end customer, we become an extension of more or less like their internal data teams. So it should operate in more of a fire and they just create all this in the self-serve UI and they expect everything is going to be working fine. They don't go back, write any code, do anything. So it is like an extension of the data teams and the internal ecosystem to enable business. This is a primary difference in terms of why observability alone is not enough. You need something above and beyond to operate your data products. The second thing, which is the fire and forget mode, which I just explained, and we aim to operate in the zero-touch ops model wherever we deploy. So with this concept, customers want at scale, data means everyone happy about scale. Everyone calls about, oh, I handle 100 petabytes of data, blah, blah, blah. So they want at scale reliability, speed, and quality. So these are the three metrics which guide what we are expecting from the tooling, okay? And pre-sales, there will be a bunch of questions. Can we answer this pre-sales? Say, for example, they'll come and tell you, hey, boss, I'm going to drop some 10 GB of file. Will I be able to utilize in my downstream data API after the processing, ingestion, et cetera, in a matter of 2 hours? And there will be quality questions like, what if a rogue data comes in? Would your pipeline break, right? And how much is the throughput and end-to-end? Suppose my website, my user is clicking or swiping for a particular event. What is the end-to-end latency before I can kind of send him a discount coupon? Because I know he is a very high-value customer. I want to immediately convert him for a sale. What is the end-to-end latency I can expect in your product? Then there will be on the API. So data delivery would be three modes, right? You will have a PubSub mode or a batch mode or API mode, which we call it as a batch, real-time, and just-in-time. So data APIs are part and parcel of any data product. So what is the latencies you can expect on an API which you give the data? Even in AI, after you do the model and everything, you will have a model serving API. So there are a bunch of tools which help in that. So API becomes a core construct in kind of any product delivery if you want to achieve this thing. The last curveball which will come in a data product, if you think about it from the data ownership perspective, they will come and ask you, hey, this is running as a black box for me. And I have my own internal regulations and InfoSec policies. So for that, can you integrate it with my tool? And it is not a very simple problem because your internal processing logs can be humongous in nature. And the moment you want to put it into your customers' tools, you will incur one additional processing cost, you will incur lots of network costs because you are aggressing not just the data, the valuable data for the customer, they also want the logs and other things, the monitoring, semantics of that. So everything kind of comes as a curveball for you. So how do you kind of manage this as well, right? So this is the pre-sale scenario, and internal ones, of course, internal, when I say it's your CSM support and the product teams, they want more of a shift-led, zero-touch ops. They want to have a very fast resolution for any instance management. They want fast RCA. Moreover, the engineers, they don't want to be afraid of putting anything in production. That was one of the core principles of DevOps and SRE. We are just applying the same principle for a data product, right? So whenever they want to make a code change and deploy it, they want a very fast feedback. Is it actually something is going wrong because of that? Because by definition, it can bring you lots of boundary conditions, okay? I believe since most are informed in this data science space, you know what is a boundary condition. So data products comes with lots of boundary conditions because it has unbounded degrees of freedom. So that is a problem we are trying to tackle. So we created an internal project almost 2.5 years back with a simple goal of creating. So what we wanted is, we wanted to be the first platform which gives a committed so-called data service level agreement, which is contractually agreed upon and given to each of the customers who's getting onboarded in the platform, okay? This will govern the time frame and the numbers around all the data points and the data sets that are going to be processed and made available for the consumption. This spans everything, the real-time, batch, just-in-time, all the distribution scenarios which we have, okay? So we had a two-phase. First is the monitor and act phase, and second is the predict and prevent phase. So with this, and the customer wants, we distilled down to two concepts. So I put a company name there. They beat us to that in terms of creating a nice PR around the data downtime as a concept. We also had a similar concept called data uptime, but data downtime is becoming more of a standard in the world of these AI and data products. So be aware of this. Data downtime is very simple. It refers to the periods of time when your data is partial, erroneous, missing, or otherwise inaccurate, okay? So if you just flip over, it is a quality, but in a time series kind of manner, okay? And it follows the same cycle of what a software bug means. If you look at the funnel at the bottom, this is like a classic software bug, right? You have this, how much it is going to cost for the company in terms of a software bug, while you find it in QA, all the way to finding it by the customer. So it closely resembles the same cycle in terms of how the software is going to work, right? Then, The second concept, this is what we introduced in terms of, because we wanted to provide data SLAs to the customer, is what we call as the data flow time. Now, flow time is a very new concept, big opportunity. There is no company out there. We are not creating a data observability tool. We created this because we wanted to make our product better, but we are fundamentally a data platform, but this is kind of, nobody in the market is providing this at this point in time. So it is a total time to take the data to move from its source to intended destination, and how to measure it, and how to ensure you create error budget on top of it, and how to ensure you give this reliability semantics, right? So what we are looking at is not just shortening of this entire data flow time. We want to make it adequate. It's not like all the use cases need real time. I know customers can be crazy. They'll say, hey, I want everything in sub-millisecond. Not necessary. Many times there will be use cases where things only happen once in 24 hours. You have this classic concept of slowly changing and fast changing dimensions. So you need to be well aware, and you need to position it properly in terms of what we are talking about. Now the measures for this, downtime, of course you want to decrease both of them. If you look at it as a mathematical function, you want to decrease both of the data downtime and the data flow time. But in data downtime, who's the first class citizen you are measuring? It is always the data quality semantics in its various avatars. Whereas in data flow time, the first class citizens becomes your pipelines and jobs. Pipeline could be a real time and batch, and job could be a one-off job, or some SQL queries and handling and all these stuff, right? And what I have put in the downstream is, how do you actually measure it? So data downtime is the number of instances. You can see the equation. And in data flow time, we are introducing two new concepts to come up with the actual data SLAs. It is called the actual flow rate and the expected flow rate. So flow rate is nothing. I'll just go over this formulas in a moment, right? From here, we derive the P99 monthly SLAs in terms of what we are able to achieve. And that is for each of the tenants. So translating it for the customers, we are primarily what we have highlighted, all contractual data SLAs. We are able to give that, and adequate quality guarantees, and the processing SLAs, and the uptime guarantees. Uptime, again, comes from the core infra and software principles of infra and software uptime, okay? Now, internal, of course, it translates to the three pillars which I internally told. And there is a small tidbit which I had to take because this is a conference and I have some bragging rights. So ZeroTap is the only customer data platform which was able to, in 2024, give a 99.95% pure uptime and a 99% data SLA. And we are trying to improve it by another 9. We are trying to make it to 3 nines this year. And beyond the tenancy challenges, which I put in the word art, what comes from a data perspective is, one is, if you think about it, I just showed a small architecture diagram in terms of a fan-in, fan-out. So the integrations explode in any data products. If you're going to put AI product would be sitting inside, but AI product might be taking multiple data streams as its input, and it'll be serving probably your customer contact center in terms of giving them better recommendations, right? So you have this bunch of challenges, both upstream and downstream, in terms of integration explosions. And there'll be lots of quirks which come in from your customers. They'll say, hey, I want a 3-legged OR. That's a little bit of advanced security in terms of how you integrate with the platform. Another customer would be okay with a basic OR. And in terms of mode, some customers will say, hey, I'll give you a Kafka, can you push it to that? Another will say, I'll expose an API, can you push it to that? Now, even in that, they'll say that, hey, Kafka, you can only push 10 GB per hour. In the API, you can hit only like 1,000 hits per second. So that is the maximum you can do. Then they can change the data formats as well. Some say Google, if you're integrating with many of the Google products, they can take only the proto-buff as a serialization format, right? So you have these various quirks which is coming in, and this is something we need to solve inside. And the observability tool should be aware of all these in a way, right? And there are data domain challenges in terms of what the catalog itself changes. Say, suppose you have multi-tenanted, the catalog of a telco company of customer 1 versus customer 2 is going to completely change. So this is something we need to be aware of. Now, multi-tenancy and observability are opposite end of the poles. Observability is trying to create a single pane of glass where you are able to see everything in a single metric. But by multi-tenant, what you're trying to do is you want to create data isolation for your customers, right? So how do we solve this? So there is an impedance mismatch. So how we do it is nothing. It's an old software engineer principle of using a global and local semantics. This may not be the, I would say, the more optimized solution, but this actually works in production. So architecture, this is a bit of a standard, as I mentioned. all the global semantics happen in the control plane in terms of metadata, metrics, and everything of the customer, and you have the common UI for the customer. Whereas your core data processing, whatever data processing which we are providing behind the scenes, that is happening in the hybrid plane of the data plane of the customer. So this very simple differentiation kind of helps you on the previous slide in terms of how to solve the observability for your multi-tenant, where these two are actually talking about two different things. Multi-tenant talks about a different end of spectrum, and this talks about different end of a spectrum. So this actually, it came as a serendipity because we started as a control plane, data plane for different purpose, but we found out it is also helping in this particular scenario as well, right? Now, a little bit of this thing in terms of data downtime, which is the first concept which we talked about. So what we do, it's simple. At each processing stage, we have an orchestrator in terms of looking at 3 levels of how the data quality is taken care of, right? One is definitely you just process the errors. Second is, as and when possible, you create a self-healing mechanism for the errors. These are all queued systems. Then the third is whatever error is happening, you want to report it and ensure there is a proper observability. When I say observability box log, from there it connects to your alerting and your various dashboards and other systems, right? But the design principle there is the bad data is never going to block the subsequent ones. So that is how you kind of reduce the blast radius of how much the rogue data can obstruct the system. So that is one. And the second thing is these are kind of the pillars on which what we are measuring. So I won't go into each of this. Many of them are kind of self-explanatory. For example, completeness. It talks about the sparseness of what both from a length and breadth perspective of your data table, how it's going to look like. Correctness, you are well aware of. Timeliness is the freshness. Standardization is like, say, for example, a data source will give a data as yum. Another will give, for mail, it will send a code as 0. You have to standardize all this into a singular catalog before you send it to that, right? And you have to have certain expectations and thresholds beyond which you can create the alerting and alerting mechanisms. So the expectation thresholds are, of course, tie back to the contract, what you're going to put with the customer. Now, this is the thing in terms of what we are giving as a downtime. So if I just mentioned this. So you have the point-in-time measurement of the data quality. You just flip it as a time series, right? You get that graph, and that is going to give you what is the 100% uptime semantics for that over a period of time. So, and our measurement semantics is at this point in time is a monthly semantics on which we operate. This is a little bit of a tech. I may not go much deep into that. Behind the scenes, what we have done is we have created our own microservices in terms of it creates a policy. So the policy contains which layer it has to act on, whether it has to act on the schema or on the data value or on the retention time and all these things. Then the action is what is the action you want to do, right? Suppose there is a quality issue, sometimes you can self-heal that. Sometimes you may need to drop it, you can't do it. And if there is a null, you want to impute it to a certain figure. So this is the various things in terms of how we do it. It's a very simple microservice with the RDBMS. So we just transposition the policies and actions, and at runtime, we know which policy to act on depending on the incoming data. Then the catalog is something, so the equation, the functional equation captures it in terms of what we are actually doing, the function of policy, and the G of parameters gives you the action to be actuated. Say, for example, there can be a blacklist, whitelist policy, and the parameters might come from the event value. You just say, hey, drop that value, because it is not really complying with the PII standards. So that is the way we operate. And this is a little bit of the runtime. I mean, again, it's a very, very self-explanatory slide in terms of how it happens. So first you do the schema level policy, then you process, you action on it, then you do the value level policy, you action on it. Then when I say our audit logs, it goes into the 3 levels of dogs. It figures out whether it can self-heal, whether it can actually, it has to be dropped, or it can do anything else, right? So this is how you get the cleansed data set. One caution here. I know we get carried away with all this. Start simple, okay? So don't directly jump into using advanced probabilistic data structures which are without analyzing how your data is looking like. Of course, we do use sketches in LLL, and don't go for a direct sampling, this multi-stage stratified random sampling and all to figure out how your error works and other things. Start with something very simple, right, in terms of counts, normal distribution analysis and all this, and then move on to the other things. Because I know many people take this broad jump, and then this kind of incurs a huge cost on top of what you're trying to do. And the results may not this thing. But if you go into the literature, This is what you will get in terms of what all you could do for a bad quality data. And this is something I always call out in terms of when I'm giving some talks on governance or quality. So you need to be aware of these scary creatures which can come with your data. So AI-ready data in IoT and many of the spaces which is coming with a timestamp is like you have a valid data plus valid timestamp. That is AI-ready, okay? You can send it to your AI and fetch the right outcomes of it. But you will have this bunch of creatures which I have listed there, right? Undead is without timestamp, and a Frankenstein has two values. One source says this is a male, another source says this is a female. Then you have this invalid data value, but with a valid timestamp, that is a toxic creature. Then you have this ghost, which has an empty data value, just your, this thing, valid timestamp is coming, in which case you need to put some techniques like imputation. Then you have a valid data value and an invalid timestamp, right? So this is the closure of the data quality, and by virtue of that, the data downtime, and data flow time comes next. We started data flow time with a very little law. It is also called the little law from the 1950s. So what it says is L is equal to lambda into W. We can apply the same thing for a pipeline. You can apply the same thing for a queue. You can apply the same thing for a query engine. And that gives you in terms of what you have to monitor. Say, for example, in a pipeline, the L, average number of records, which is there, unprocessed. That is what you are. And lambda is the arrival rate. What is your TPS which is coming in? And W is the how much is each processing taking. So that is what you are measuring. So like this, if you can break it down for each of the various workloads, you can figure out what exactly you want to monitor. It gives you a simple set of variables to monitor. And now we know what to observe. What is the SLA? So SLA, very simple again in terms of the end time of the last stage of your processing minus the start time of the first stage of processing. I'll also tell you in our architecture how we actually calculate it, because this is, again, the control plane, data plane semantics helps us in that. And from here, we create the monthly SLAs in terms of how much error we have caused for a customer, right, in terms of the time deltas. Then what are the entities measured, the workflow, data set, data points? So these are all first-class citizens. As I told, the jobs in pipeline become a first-class citizen. They have a specific this thing there. And the metrics example, I just listed a bunch of examples. So API, everyone knows the 5xs codes and the 200 codes gives you the reliability semantics. Like that for each of this, the flow time, reliability, which you already mentioned. And the tool sellers, if you look at, I just showed that amalgamation metrics, they will come and tell you, oh, you send me all unstructured logs, I'll take care of everything for you. It'll be shitty expensive. Don't do that, okay? Good old logging wisdom still applies. Define your grammar. Ensure your people follow that grammar when you're architecting any of these systems. Then ensure you're able to put it on any cheap storage and it is actually queryable, right? So I just listed a couple of things in terms of what the logs grammar should include. And a simple prod story. So for example, there was a sudden drop of the aggression volume on multiple egress channels. So this raised a volume alert and a sparseness alert. Think about it, if the volume drops, you may not get logs. So there is no log alert here. You have to rely on the data quality alerts, which I talked about. That's why I mentioned logs may not be sufficient for a data observability. So you have the volume alert and sparseness alert, and in a period of 1 hour, team figured out, less than 1 hour in fact, team figured out the sparseness alert has come from the consent master, and the consent master, we store everything, every attribute with the lineage from which source it comes. We figured out one of the sources not stopped sending, and we checked whether it is our problem, whether we released something. When it was not that internally Zeotap release, we notified the customer, they figured out, okay, they have made some small change in terms of how the pixel is generated, and it was all fixed. So the incident, so this is what I called about the internal piece, right, which we want to create. Now, some reference works. So this is how our internal architecture works. So we have 2 homegrown systems, Kingpin and Symphony, which helps in the entire downtime calculation. And we have the classic dashboard alerts and pager on top of it. And we have got a new kid in the block. There are a bunch of new observability tools, which is based on eBPF. eBPF is a kernel framework in Linux, where you can create traceability in the kernel space, not in the user space. That's a new tech which is coming in. So we have just introduced that, and it has been just 1.5 quarters, so we are yet to measure the entirety of the success of that project, but till now we have been on homegrown systems. And this is a very simple infra example, right? So what are the resources you monitor for your data stuff, and what are the telemetry feeds you get, what are the metrics you want to monitor, and what are the alerts and delivery. This is for the proactive monitoring system in terms of, so the singular metric what our company or the support team operates on is how many bugs are you able to, when I say bugs, how many downtimes are you able to figure out before the customer figures out? So that is a very, very simple North Star metric on which we operate on, and we want to optimize that metric. So some internal results on that key North Star metric, customer reported to internal finding. The target is set for less than 20% should be there. Say suppose 100 issues are coming, only 20 issues should be reported by the customers. At this point in time, we are at approximately 30%. It's like a weight loss program, so the last miles would be always very difficult to achieve, but we are getting there. Then SLA embedded architecture as a culture is in the team. Then the other collateral we got is a huge cost reduction in all this, right? Then that can be passed on to your customer in terms of better pricing. So just one more slide, some creds, again bragging rights in terms of what we are talking about here. We are monitoring close to 1,800 data pipelines, of which 300 are end-to-end real-time pipes. And we have data APIs at less than 100 millisecond P99s. And we achieve throughputs of close to 200K TPS per this thing. And the egress, we are very heavy on egress. We egress close to 20 billion data points a day from the platform in terms of what we are operating on. And future scope, this is for anybody who wants to bootstrap companies in this particular space. The log information retrieval and storage is very, very immature. It is now a very string format. You have graph neural networks, very good advanced techniques there which can be used for this. Then the eBPF, which is a framework, now only companies, I think as of now, there are 4 companies who have started eBPF first. There are a couple of companies who are retrofitting their platform to get into that. Then the agentic POC, we are doing something with Gemini to convert our support agents and this entire proactive monitoring into an agentic system, but that is still this thing. But when you are doing this, beware, you are chasing a moving goalpost because data dimensions keep on changing on a daily basis. So you need to be aware of that. There is quite a stress in the system in terms of what is happening. And we are seeing a new breed of engineering coming, just like the SREs of yore. They are called the data reliability engineers. So this is what we think as the future. Thank you.